Hello everyone, today we learn about the application of Ampere's law. The second application is infinite sheet of the current. First, we consider an infinite current sheet in the Z equal to 0. So the current sheet at the Z equal to 0. The second one, the sheet has a uniform current density K equal to Ky. Ky is a constant, y is the direction. Ampere per meter. So we can see that the current moving toward the y direction with the constant Ky. So on the sheet we have the closed path, or we call it Amperian path, which is the current go through inside the closed path. So applying Ampere law to the rectangular closed path. So the closed path, we name it 1, 2, 3, 4, and the direction is 1 to the 2, 2 to the 3, 3 to the 4, 4 to the 1. And the mathematical equation is the integral of closed path h dot dl equal to I enclosed equal to k with the direction of y time b. Why the time b? Because I enclosed equal to the integration of j ds. J is the current of the surface and ds is the surface length. So k is the current of the surface with direction of y, and b is the surface length. Because why we take a b? Because current toward to the y direction, so we take a b. Then we know that AV equal to AL cross A rho. So AL is the direction of the current. A rho is the direction of the radius. In this case, AL, the direction of the current towards to the y direction. So the dot black is a Amperian path or closed path. And the direction of radius we take from origin to the point of H at the z-axis. So the direction of the radius rho is a z direction. So we use the cyclic permutation AV equal to y direction cross z direction. We will get the x direction. So we can draw the symmetrical pair of the current filaments with the current along y direction. So we know that from previous, the AV, the magnetic field in x direction. So we took point 1 and point 2 from the rectangular closed path. And we can see that, we can draw that at H field point at the z-axis, the direction of H towards to the x direction. Same with the mirror, with the negative part, when z less than 0. So the direction of H field toward to negative x direction. So we can conclude that in the mathematical equation of H, the H field equal to, we took that H naught with the direction of x when the z is larger than 0. So H equal to negative H naught with direction of x when z less than 0. Why we take a H naught? Why we denote as H naught? Because H naught we denote as a constant. Then from the rectangular, we know that the closed part of HDL equal to the line part 1 to the integral of line part from 1 to 2 plus the integral of line parts from 2 to 3, the integral of line part from 3 to 4 plus the integral of line part from 4 to 1 h dl. So the line part like this. So from point 1 to point 2, point 2 to point 3, point 3 to point 4, and 4 to point 1. This is the rectangular of closed path, or we call it Amperian path. So we integrate first from point 1 to point 2. So point 1 to point 2, the point is toward to, the magnetic field is toward to negative z direction. So toward to negative z direction, and the length dl also toward to the negative a. So at the vertical is a and the horizontal is a b. So when we know that from previous h direction, the using the cyclic permutation, the h direction is in the x direction, so no h direction, so no z direction. So when h in the z direction is equal to 0, so the dl is a negative a because the direction is toward to negative z. So the integral from line 1 to line 2 equal to 0. So what happened with integral from line 2 to line 3? So we know that the integral from line 2 to line 3 is a toward to the h is a toward to the x, negative x direction. So we do that negative h naught x direction dot, because they're towards the negative x, so the b is also negative b. In the negative b time is a negative x direction. So h naught time b for line 2 to the line 3. Same with line 3 to line 4. We know that h naught at the z direction. So because toward to the positive z direction, and the length a also in the positive z direction. So but h field in x direction. So for when h field in z direction is equal to 0. So the final answer is equal to 0. And the last one is the from line 4 to line 1. So the integral of h dot dl, we know that h naught is a constant, h naught with the direction of the positive x, dot b with the direction of the positive x. So the final answer is h naught b. So when we sum up from all the parts, so the closed integral of h dl equal to 0 plus h naught b plus 0 plus h naught b equal to 2h naught b. Then from the equation, we know that previous equation, h dl, the closed integral of h dl equal to I enclosed equal to kyb. The closed integral of h dl equal to 2h naught b. So when we substitute from 1 to 2, kyb equal to 2h naught b. So h equal to h naught equal to half ky with direction of x. So we can conclude that h field equal to half k in the direction of y, k in the direction of y with direction of x, z larger than 0, and another one negative half k with direction of y, but h is in the direction of x, z less than 0. In general, for an infinite sheet of current density k ampere per meter is h equal to half k cross with the unit vector. So AN is a unit vector directed from current sheet to the point of the interest.